Java application in Java database connectivity. Now we are focusing on Java application. The Java application, the application written in the Java programming language is responsible for interacting with the user and for invoking JDBC API functions. These API functions submit SQL statements for processing by a file system or a database management system. The Java application uses interfaces, classes, and methods that are defined by the Java API to access data source. Here you can see Java and the database. JDBC is a SQL level API, one that allows you to execute SQL statements and retrieve the results, if any. API itself is a set of interfaces and classes that designed to perform actions against any database. The interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Interface statement, the object used for executing a static SQL statement and returning the result it produces. By default, only one result set object per statement object can be open at the same time. Therefore, if the reading of one result set object is interleaved with the reading of another, each must have been generated by different statement objects. All execution methods in the statement interface implicitly close a current result set object of the statement if an open one exists. Interface prepared statement, an object that represents a precompiled SQL statement. A SQL statement is precompiled and stored in a prepared statement object. This object can then be used to efficiently execute this statement multiple times. Interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes a result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input output or both. Parameters are referred to sequentially by number, with the first parameter being 1. Interface connection. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. A connection object's database is able to provide information describing its tables, its supported SQL grammar, its stored procedures, the capabilities of this connection, and so on. This information is obtained with the get metadata method. You can see here class driver manager, the basic service for managing a set of JDBC drivers. Here you can see result set is connected to statement. Here result cells is connected to prepared statement. Result set is connected to callable statement. Statement, prepared statement, callable statement interacts with the connection. Connection interacts with driver manager. Driver manager interacts with Oracle driver or JDBC or DBC bridge and Sybase driver here. Oracle driver interacts with Oracle database. JDBC or DBC bridge interacts with ODBC driver. ODBC driver interacts with ODBC database. Sybase driver interacts with Sybase database. Here you can see a relationship of the connection to other objects. To illustrate the importance of the connection object, this figure shows how connection objects are created. Class T in package java.lang in module java.base. Instances of the class represent classes and interfaces in a running Java application. An enum class and a record class are kinds of class. An annotation interface is a kind of interface. Every array also belongs to a class that is reflected as a class object that is shared by all arrays with the same element type and number of dimensions. The primitive data types boolean, byte, char, short, int, long, float, and double, and the keyword void are also represented as class objects. Interface driver in package java.sql in module java.sql. The interface that every driver class must implement. Class driver manager, the basic service for managing a set of JDBC drivers. Note the data source interface provides another way to connect to a data source. The use of a data source object is the preferred means of connecting to a data source. The interface data source in package javax.sql, a factory for connections to the physical data source that this data source object represents. An alternative to the driver manager facility, the data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. Interface connection in package java.sql in module java.sql. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Interface statement in package java.sql in module java.sql. The object used for executing a static SQL statement and returning the results it produces. Interface prepared statement in package java.sql in module java.sql. An object that represents a precompiled SQL statement. The interface callable statement in package java.sql in module java.sql. The interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes the result parameter and one that does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Here the java.lang.class is connected to driver via new instance. Here the driver is connected to connection via connect. Here driver manager is connected to connection via get connection. Here the javax.sql.data source is connected to connection via get connection. Here the connection is connected to statement via create statement. Here the connection is connected to prepared statement via prepared statement. Here the connection is connected to callable statement via call. Here statement is connected to prepared statement via subclass, and prepared statement is connected to callable statement via subclass. Here you can see a relationship of result set to other classes and interfaces, classes or interfaces. To show how the importance of the result set object, this figure shows the interfaces and relationships between the key classes and interfaces in the java.sql package. The figure also shows the methods involved in creating statements, setting parameters, and retrieving results. For details, please use the final release of the JDBC specification. As you can observe from the low-level class or interface relationships, to connect to a relational database, you must use an instance of the connection object. To get the connection object, you need to provide database URL, username, and password. Then to find out the names of the database views, tables, and columns, so-called metadata. You need to get an instance of database metadata. database metadata object from the connection object. Next, to issue a SQL query, you compose the SQL query string and use the connection object to create statement object. By executing the statement, you obtain the results result set object. And to find out names of the column rows in the result set, you need to obtain the instance of the result set metadata object. Interface connection in package java.sql in module java.sql. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Interface database metadata. Comprehensive information about the database as a whole. Interface statement, an object used for executing a static SQL statement and returning the results it produces. Interface prepared statement, an object that represents a precompiled SQL statement. Interface callable statement, the interface used to execute SQL stored procedures. The JDBC API provides a stored procedure SQL escape syntax that allows stored procedures to be called in a standard way for all RDBMSs. This escape syntax has one form that includes the result parameter and one that does not. If used, the result parameter must be registered as an output parameter, and the other parameter can be used for input, output, or both. Parameters are referred to sequentially by number, with the first parameter being 1. Interface result set, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. Interface result set metadata, an object that can be used to get information about the types and properties of the column in result set objects. The following code fragment result set of objects. Here you can see the connection. Connection is connected to database metadata via get, and here connection is connected to statement via create statement. Here connection is connected to prepare statement via prepare statement, and connection is connected to callable statement via prepare call. And here statement is connected to result set via execute query, and prepare statement is connected to result set via execute query, and callable statement is connected to result set via execute query, and result set is connected to result set metadata via get. And here result set is connected to data types via get xxx, and data types is connected to prepare statement via input, and callable statement interacts with data types via input or output. Here statement is connected to prepare statement via subclass, and prepare statement is connected to callable statement via subclass. Here you can see steps to design JDBC applications in Java. in this article, we are going to discuss the steps to design JDBC applications in Java with Java. Let us understand how to perform crude operations in Java application using JDBC step by step. This diagram shows the different steps required to develop a JDBC application in Java. Let us discuss each step in detail. Establishing connection. In the JDBC programming model, the first step is to establish the connection between the Java application and the database server. Establishing the database connection in Java program involves two steps. Step 1, loading JDBC driver from secondary memory into primary memory. First, you need to load the driver or register it before using it in the program. Registration is to be done once in your program. In java.lang.class, there is a static method forName. This method is used to load JDBC driver into application process space. You can register the driver by following two ways. One, class.forName, driver class name. Here we load the driver's class file into memory at runtime. No need of using new or create an object. Two, driver manager.register driver method. Driver manager is a Java inbuilt class with a static member register. Here we call the constructor of the driver class at the compile time. When the forName method is successfully executed, three things happen in the background. 1, the driver class is loaded into memory. 2, the driver class object is created. 3, the driver class is registered with the driver manager. Step 2, requesting for a connection object. In order to establish a communication with the database, you must first open a JDBC connection to the database. After loading the driver, establish a connection. In java.sql.driverManager class, there is a static method getConnection. This method is used by the Java program to request the database connection. Following three methods of driver following are the three methods of driverManager.getConnection. 1, getConnection string URL. 2, getConnection string URL properties prop. 3, getConnection string URL, string user, string password. Once the statement is executed, the client connects to the database server object. The object oriented representation of JDBC client session with the database server is nothing but java.sql.connection object. Note, internally getConnection method call connect method of connection class. Creating statement object. Once the connection is established, you can interact with the database. The create statement method of the connection interface is used to create a statement. The object of the statement is responsible to execute queries with the database. The statement object is designed to submit SQL statement from JDBC client to the DBMS via JDBC driver. Submitting the SQL statement. Now it is time to process the result by executing the query. The java.sql.statement object has two important methods to submit SQL statement to DBMS. 1, execute update string DML. The execute update string query method of the statement interface is used to execute queries of updating or inserting. This method is used to submit DML, insert, update or delete SQL statement. 2, execute query string DRL. The execute query method of the statement interface is used to execute queries to the database. This method returns the object of result set that can be used to get all records of a table. This method is used to submit the select statement. Close the connection. So finally, we have to send the data to the specified location by closing the connection object statement, and the result set will be closed automatically. The close method of the connection interface is used to close the connection. Here you can see establish connection is connected to create statement object. Create a statement object is connected to submitting the SQL statement. Submitting the SQL statement is connected to processing and presenting of the request. Here processing and presenting of the request is connected to one or more CRUD operation. If it is yes, it's connected to submitting the SQL statement, and if it is no, then it's connected to closing the statement. Closing the statement is connected to closing the connection. As an example, we can consider here Java database connectivity. Java database connectivity JDBC API. The Java database connectivity JDBC API provides universal data access from the Java programming language. Using the JDBC API, you can access virtually any data source, from relational databases to spreadsheets and flat files. JDBC technology also provides a common base on which tools and alternative interfaces can be built. Packages include java.sql, javax.sql. As example 2, we can consider module java.sql defines the JDBC API. Here you can see the module graph. Java.sql here you can see Java.sql module. This module exports Java.sql package and javax.sql package. Indirect exports java.util.logging package from java.logging module. javax.transaction.exe package from java.transaction.exe module, and javax.xml, javax.xml.catalog, etc. from java.xml package, our java.xml module. So java.sql module requires java.logging module defines the Java logging API, and java.sql module requires java.sql XML module defines the Java API for XML processing, JAXP, the streaming API for XML, STAX, the simple API for XML, SAX, and the W3C document object model, DOM API. And Java.sql module requires java.transaction.exe module defines an API for supporting distributed transactions in JDBC. Jar.logging and jar.xml and java.transaction.xa modules requires java.base module, defines the defines the foundational APIs of the Java SE platform. As an example 3, we can consider package java.sql, provides the API for accessing and processing data stored in a data source, usually a relational database, using the Java API, Java programming language. This API includes a framework whereby different drivers can be installed dynamically to access different data sources. Although the JDBC API is mainly geared to passing SQL statements to a database, it provides for reading and writing data from any data source with a tabular format. The reader-writer facility available through the javax.sql.raw set group of interfaces can be customized to use and update data from a spreadsheet, flat file, or any other tabular data source. This package is in module java.sql. This package, the java.sql package contains APIs for the following: making a connection with the database via the driver manager facility, includes a driver manager class, SQL permission class, driver interface, driver property info class. Sending SQL statement to a database, statement, prepared statement, callable statement, connection, interface, and save point. Next point is retrieving and updating the results of a query, result set interface. Next point is standard mappings for SQL types to classes and interfaces in the Java programming language. Array interface, blob interface, club interface, date class, enclub interface, ref interface, row ID interface, struct interface, SQL XML interface, time class, timestamp class, and types class. Next point is custom mapping and SQL user defined type UDT to a class in the Java programming language, SQL data interface, SQL input interface, and SQL output interface. Next point is metadata, database metadata interface, result set metadata interface, and parameter metadata interface. Next point, the last point is exceptions, SQL exception, SQL warning, and batch update exception. As an example 4, we can consider the module, the package javax.sql provides the API for server-side data source access and processing from the Java programming language. This package supplements the java.sql package, and as of the version 1.4 release is included in the Java Platform Standard Edition Java SE. It remains an essential part of the Java Platform Enterprise Edition Java EE. This package is in the module java.sql. The javax.sql package provides for the following: 1. The data source interface as an alternative to the driver manager for establishing a connection with the data source. 2. Connection pooling and statement pooling. 3. Distributed transactions. 4. Raw sets. Applications use the data source and raw set APIs directly, but the connection pooling and distributed transactions APIs are used internally by the middle tier infrastructure. As an example 5, we can consider this code segment. Here you can see a interface connection, a connection session with a specific database. SQL statements are executed and results are returned with the context of a connection. Interface statement, the object used for executing a static SQL statement and returning the results it produces. Here in create statement, creates a statement object for sending SQL statements to database. Here the execute query method execute the given SQL statement, which returns a single result set object. Here the result set interface, a table of data representing a database result set, which is usually generated by executing a executing a statement that queries the database. Here the next moves the cursor forward one row from its current position, and here the get int retrieves a value of a designated column in a current row of this result set object as an int in the Java programming language. In get string retrieves the value of the designated column in the current row of this result set object as a string in the Java programming language. Here get float retrieves the value of the designated column in the current row of the of this result set object as a float in the Java programming language. In the following example of setting a parameter, con represents an active connection. The interface prepared statement, an object that represents a precompiled SQL statement. We can consider this code segment as example 7. STMT is the callable statement. Here the interface callable statement, the interface is used to execute SQL stored procedures. The JDBC API provides the stored procedure SQL escape syntax that allows stored procedure to be called in a standard way for RDBMS. This escape syntax has one form that includes a result parameter and one form does not. If used, the result parameter must be registered as an out parameter. The other parameters can be used for input, output, or both parameters. Parameters are referred to sequentially by number, with the first parameter being 1. Here the register the out parameter before calling the stored procedure. They read the out parameter now. Now we are considering connections. A connection object represents a connection to a data source via a JDBC technology enabled driver. Here the interface connection in package java.sql in module java.sql. A connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. The data source can be a DBMS, a legacy file system, or some other source of data with the corresponding JDBC driver. A single application using JDBC API may maintain multiple connections. These connections may access multiple data sources, so they may all access a single data source. From the JDBC perspective, a connection object represents a client session. It has associated state information such as user ID, a set of SQL statement and results sets being used in that session, and what transaction semantics are in effect. To obtain the connection, the application may interact with either a driver manager class working with one or more driver implementation or a data source implementation. Using data source objects is the preferred method because it enhances application portability, it makes code maintenance easier, and it makes it possible for the application to transparently make use of connection pooling and distributed transactions. All Java EE components that establish a connection to a data source use a data source object to get a connection. Now we are considering transaction boundaries and auto commit. We are considering disabling auto commit mode in transaction boundaries and auto commit in transactions. This code example shows how to disable auto commit mod. The method set auto commit boolean auto commit in interface connection in package java.sql in module java.sql sets this connections auto commit mod to the given state. If the connection is in auto commit mode, then all its SQL statement will be executed and committed as individual transactions. Otherwise, its SQL statement are grouped into transactions that are terminated by a call to either the method commit or the method rollback. By default, new connections are in auto commit mode. Here the setting auto commit off. When auto commit is disabled, each transaction must be explicitly committed by calling the connection method commit or explicitly rollback by calling the connection methods rollback respectively. This is appropriate for cases where transaction management is being done in a layer above the driver, such as when the application needs to group multiple SQL statements into a single transaction, when the a transaction is being managed by the application server. The default for auto commit mode to be enabled when the connection object is created. If the value of the auto commit is changed in the middle of a transaction, the current transaction is committed. If the auto commit is called and value for auto commit is not changed from its current value, it is treated as no op. It is an error to enable auto commit for a transaction for a connection participating in a distributed transaction. Here the assume con is a connection object. Now we are considering two-phase commit in transaction management in distributed transactions. Here you can see the starting and ending transaction branches using XA resource interface. The following steps outline how a transaction manager uses XA resource objects to implement the two-phase commit protocol. These steps assume a three-tier architecture where an application server is working with an external transaction manager. The application server step one, the application server gets XA resource objects from the two different connections. Here the getting XA resource object from XA connection. Step 2, the application server passes XA resource objects to the transaction manager. The transaction manager does not access the associated XA connection object directly. Step 3, the transaction manager uses XA resource objects to assign a piece of transaction to each of the associated resource managers. The transaction is identified by XID, which represents the identifier generated by the transaction manager when the transaction is created. Here you can see the starting and ending of the transaction branches using XA resource interface. Step 4, the transaction manager initiates the two-phase commit protocol by asking each participant to vote. Here the initiating two-phase commit. A participating resource manager can vote to rollback transaction by throwing java x.transaction.xa.xa exception. Step 5, both participant vote to commit. The transaction manager tells each one to commit its piece of the distributed transaction. The second parameter tells the resource manager not to use the one-phase commit protocol on behalf of XID. Here the committing the database, committing the distributed transaction here. Step 6, if the resource manager wants to roll back, the transaction manager tells each one to roll back its piece of transaction. Here you can see the rollback, the distributed transaction. Transaction manager is not required to use the same XA resource object to commit or rollback. Commit to rollback a transaction branch as was used to execute the branch. If a different XA resource objects are used, however, they must be associated with the XA connection objects that connects to the same resource manager. Note these steps also apply to the case where XA-con A and XA-con B are physical connection to the same resource manager. Here the XA-con A connects to a resource manager A. Here the XA-con B connects to a resource manager B. Here the send to resource manager A send work to resource manager A. The TM and all TM no flags argument indicates we are starting a new branch of transaction, not joining or resuming an existing branch. Do work with resource manager A. Tell the resource manager A that it's done and no errors found. Now no errors have occurred. Do work with the resource manager B. B is part of the distributed transaction. Now we are considering creating statements in statement interface in the statement interface in the statements. Here they creating multiple statement object from a single connection. Module the interface is statement in package java.sql in module java.sql. The object used for executing a static SQL statement and returning the results it produces. Statement objects are created by connection objects, as it is done in connection objects. Each connection objects can create multiple statement objects that may be used concurrently by a program that is demonstrated in this code example. Here the get a connection from the data source object ds. Here create two instances of statements. Now we are considering statements in description of batch updates in batch updates. Here creating and executing a batch of insert statements. The batch update facility allows statement objects to submit a set of heterogeneous SQL statements together as a single unit or batch to the underlying data source. Since the JDBC 2.0 API, a statement object has had the ability to keep track of a list of commands or batch that can be submitted together for execution. When a statement object is created, its associated batch is empty. An application adds a command to the statement batch one at a time by calling the method statement.add batch and providing it with the SQL statement to be added. Any of the commands added to the batch must return a simple update count and must not return a result set. If an application decided not to submit a batch command that has been constructed for a statement, it can call the method statement.clearBatch to clear the batch of all commands. In this code example, all the SQL statement required to insert a new employee into a fictitious company web database are submitted as a single batch. In the example, autocommit mod is disabled to prevent the driver from committing the transaction when statement.executeBatch is called. Disabling autocommit allows the application to decide whether or not to commit the transaction in the event that an error occurs and some of the commands in the batch cannot be processed successfully. For this reason, auto commit should always be turned off when batch updates are done. The commit behavior of execute batch is always implementation defined. When an error occurs and auto commit is true, it is not possible to set a save point within a batch statements to enable partial recovery. If a save point is set any time before the method execute batch is called, it is set before any of the statements that have been added to the batch are executed. Although the focus of this section is on using statement objects to do the batch updates, you can have a separate discussion that follows applies to prepared statement and callable state objects as well. Note, if your database supports the returning an update count that may exceed the integer max underscore value, use the method execute large batch. Here the turn off auto commit. Submit a batch of update commands for execution. Now we are considering creating result set objects in creating and manipulating result set object in result sets. Here executing a query returning a result set object. The interface result set in package java.sql in module java.sql, a table of data representing a database result set, which is usually generated by executing a statement that queries the database. The result set objects is most often created as the result of executing a statement object. The statement methods execute query and get result set both returns the result set objects. Do various database metadata methods. This code example execute SQL statements returning a result set object. Here the executing a query returning result set object. For each book in the table book list, the result set object will contain a row consisting of 3 columns: author, title, and ISBN. Now we are considering creating blob, club, and nclub objects in blob, club, and nclub objects in advanced data types. Here, creating and writing bytes into a blob object. The connection interface provide support for creation of blob, club and enclob objects using methods create blob, create club and create enclob. The objects that is created does not contain any data. Data may be added to the object by calling one of the set xxx methods in the blob, club or enclob interface. In this code example, the method connection dot create blob is used to create an empty blob object. Blob dot set bytes is used to write data to a blob object. Here you can see creating and writing bytes to blob objects. Now we are considering type mapping in customized date type mapping. Here putting an entry in a connections type map. The method void set type map string class map in interface connection in package java.sql and in module java.sql. Install the given type map object as the type map for this connection object. The type map will be used for connection for the custom mapping of SQL structured type and distinct types. The SQL user defined types UDTs and structured type and distinct types can be given a custom mapping to a class in the Java programming language. The default is the driver to use the default mapping between SQL data types and types in the Java programming language. The default mapping for an SQL structured type is to the interface struct. The default mapping for an SQL distinct type is to the type to which the underlying type is mapped. If a connection, if the custom mapping has been set up for a UDT, the driver will use the custom mapping instead of the default mapping when an application calls the get object or set object methods on that UDT. Setting up a custom mapping requires two things. One, writing implementation of SQL data interface for UDT. This class typically maps the attributes of a SQL structured type or a single attributes of the distinct type to fields. There is, however, great latitude allowed in how a UDT is custom mapped. It is expected that most SQL data implementations will be creating using a tool. Two, putting an entry in a Java util.map object. The entry must contain the following two items: a fully qualified name of the SQL UDT that is to be mapped. B, the class object for SQL data implementation. It is an error if the class listed in a type map entry does not implement the SQL data interface. For example, if the UDT name my scheme name dot authors and the SQL data implementation is the class authors, the entry for the type map associated with the connection object con would be like this code example. Here the putting an entry in connection type map. The method connection dot get type map returns the type map associated with the connection object conn. The method connection dot set type map sets the given java.util.map object as the type map for conn. When a SQL value with the custom mapping is being retrieved by the method resultSet.get object or callable statement.get object or any other methods that materialize the SQL values data on the client, the driver will check to see if there is an entry in the connections type map for the SQL value that is to be retrieved. If there is, the driver will map SQL UDT to the class specified in the type map. If there is no entry for UDT in the connection type map, the UDT is mapped to the default mapping. Certain methods may take a type maps as a parameter. A type map supplied as a parameter supersedes the type map associated with the connection. A UDT that does not have an entry in the type map supplied as a parameter will be mapped to the default mapping. When type map is explicitly supplied to the method, the connections type map is never used. Now we are considering system contracts in relationship to connectors. The following standard contracts are defined between an application server and a data source system. A connection management contract that enables application components to connect to a data source. A connection management contract is equivalent to the services distributed by the JDBC interfaces, data source and connection pool data source. A connection management contract between transaction manager and a data source supporting transactional access to its resources. The transaction contract is equivalent to the services described by the JDBC interface X data source. A security contract that enables secure access to a data source. The security contract does not have an equivalent in the JDBC API. Authentication in the JDBC API always consists of providing a username and a password. A system contract defined in the contract specification describes the interface between an application server and one or more resource adapters. This interface allows the resource adapters to be bundled in such a way that it can be used by any application server that supports the system contracts. The JDBC specification does not make distinction between an application programming interface API and the SPI. However, a driver can map the JDBC interfaces in the SPI to the connector system contracts. Now we are considering isWrapper4 method in wrapper interface, methods in wrapper interface. The interface wrapper in package java.sql in module java.sql, the interface for JDBC classes, which provide the ability to retrieve the delegate instance when the instance in question is in fact a proxy class. The isWrapper4 method can be used to determine if the instance implements the specific interface or if the instance is wrapper for an object that does. If the object implements the specified interface, then the value of true is returned. If the instance is a wrapper, then the method isWrapper4 is recursively called on the wrapper object. If the instance does not implement the interface and is not a wrapper, a value of false is returned. This method should implement a low cost operation compared to calling unwrap method. If the isWrapper4 method returns true, then the calling unwrap method with the same interface must succeed. This code example provides an example of using the wrapper interface methods. Here the using isWrapper and unwrap methods. Now we are considering JDBC types mapped to Java types in data type conversion tables. Here the JDBC type char and the Java type, the matching Java type is a string. Now we are considering numeric function in Scala functions. The function name ABS number. The function returns absolute value of number. As an exception example, we can consider SQL exception. The class SQL exception, an exception that provides information on a database access error or other errors. This is in the module java.sql and in the package java.sql. Now here we are considering navigating SQL exceptions in exceptions. The following code segment demonstrate how an application could navigate SQL exceptions and their causes. The class SQL exception in package java.sql in module java.sql, an exception that provides information on a database access error or other errors. It is possible that during the execution of a SQL statement that one or more exceptions could occur, each with their own potential causal relationship. This means that when the JDBC application catches a SQL exception, there is a possibility that there may be additional SQL exceptions chained to the original thrown SQL exception. To access the additional chain SQL exceptions, an application would recursively invoke get next exception until a null value is returned. The SQL exception may have causal relationship which consist of one or more throwables which caused the SQL exception to be thrown. You may recursively call the method SQL exception .getClose until a null value is returned to navigate the chain of causes. The following code segment here demonstrate how an application could navigate SQL exception and their causes. Here navigating SQL exception and their causes. As an error example, we can consider JDBC connection errors in the environment with IBM Netcool Omnibus. The description is connection errors are typically caused by incorrect or invalid connection with string parameters such as invalid hostname or database name. The action is to verify that you are using correct and valid connection string parameters for the get.jdbc.url